All right. So I just wanted to make sure that y'all got a chance to see how to do this problem since class didn't go quite the way I expected it to. So let's take a look at this one. What we want to focus on in this problem is the mean and standard deviation that's given per jet. So that's the information given. That's going to be the population mean and population standard deviation. So for the problem that we have, we take a look here. We're looking kind of at an aggregate of some number of jets. In this case, that answer is 39. So as we take a look at this, it takes 39 jets, 320 minutes. We want to backtrack this to an average per jet. That's going to be our first step. So as we're going through this, I'm going to show you how to do part A. And then once you know how to do part A, the same process happens for part B with just a different aggregate number here. And then once you have A and B, you should be able to get C. So we are I'm going to show you how to do this on the board as we go across doing this. So we have 320 minutes and 39 jets as we take a look at that. So here's what we're going to do for this one. First step is to know that we have a mean sitting here of 8.4. And then we have a standard deviation equal to 3.1. We have a total of 39 jets. And so what we want to do is we want to find our X bar. And our X bar is going to be the 320 total minutes divided by the 39 jets. So we have to calculate what that value is. We go to our calculator. We type it in and we get 8.2051281. I'm going to keep writing out all these numbers because we just want to be a little bit careful with the rounding. If we round too early in the process, our answers could potentially be incorrect. So I'm going to wait to the very end to round my answer, and then we'll be able to use all the tools we need to make sure we get a correct answer on the back end. So I've got 8.205, blah, blah, blah. So the next step in this is to compute a Z value. So because we have a sample size and sample mean, we are going to use the Z value that includes the sample mean and sample size. So then we just plug in the numbers that we have. And we see what we get on the back end. So I'm going to take my answer. I'm going to plug this into the calculator. I might just take us a second. And we should get an answer that looks something like 0.22178 as we take a look at that. I'm going to round it here because once we get here, that's kind of the end result that we want to be at on this problem. All right. So now that we have that, what we will do is we're going to come back into here, and I'm going to go into the salt tool because the problem tells you to use salt. We have a normal distribution. We have a mean standard deviation. That's really not going to be overly relevant in this problem because what we're going to do is we're going to plug in a Z-score that we just computed. And we're going to see what we're going to get. First thing, make sure that this one was a negative value. That was a negative 0.21178. So I'm going to plug that in, negative 0.21178. And when I hit that value right there, I should get my area to the left, 0.41614. And so that's how we do this problem going forward. So then on the next one, it was 275. We would take a look at the number 275, figure out what that is, and so on and so forth. So that's it. All right, hope this helps.